Last week we have studied about various embedded programming languages such as embedded C++, then embedded Java, etc. And we have seen various advantages and disadvantages of these programming languages. Today we are going to learn about software testing, software validation and software debugging. These are the topics which we will cover in this session. Initially, I'll give an introduction to software testing. Software testing is a method by which developer test and find out the error in their program. And there are a lot of methods to test a program. For example, we can use static code analysis and dynamic code analysis for testing program, and black box analysis and white box analysis for testing a software. After the testing, we will go through software validation. In software validation, we will check whether our developed program is met the requirement of our customer. And in last part of our topic, we will cover debugging process and technique. Here we will understand how to debug a program, how to rectify the error in our program like that, and various methods for doing it. A software can be think as a collection of programs, and each software has designed to run some particular task or designed to have some particular functionality. And here we use software testing to ensure whether the software perform its designed task perfectly within the time constraints. For example, we can consider a calculator, and the calculator program should do the calculation perfectly within the time constraint, such as it should give the calculation output within 0.1 second. And suppose we give an input during the testing phase, we give two input to the calculator, and for example we give input 10 and input 20, and give the and set the operation as addition. So the calculator should perform the addition of two numbers 20 and 10 and give the output 30. But if the calculator give the output as 40, then we can say that the calculator is faulty. So the program should be re-implemented. Sometimes the design also need to be re-implemented or redesigned. Similarly, if we give the input 20 and 10 and we get the output as 30, but it takes 10 seconds to get the output, then we can say that it is not doing it in intended functionality, because we need the output within its time limit 0.1 second, but we get the output after 10 seconds, so that this software is faulty. So we have to redesign it. Okay, so we can say that software testing is an activity to check whether the actual result match the expected result, and to ensure that the software system is defect free. These are the goals of software testing. The first goal of software testing is bug prevention. We know it is better to prevent the fault and the problems of a software at the early stage of development. And if we found out the problem at the early stage of development, then we can easily remove the problems. And the second goal of our software testing is bug detection. Before
delivering our product to the customer, we have to root out all the fault and malfunctions. And the third goal of our software testing is user satisfaction. Here we will check whether our software will comply with the user requirement. If our software is not satisfying the user requirement, then we should redesign our software and then we should re-implement it. And next goal of our software testing is software quality and reliability. And here in the case of an embedded system, we will check whether our software is operating perfectly for all the designed environmental conditions.
During testing, we should consider following parameters. First, we need to check whether the software should satisfy all the customer needs and requirement. If the software doesn't satisfy all the customer needs and requirement, then we should redesign it and re-implement it, because the customer is paying money for the software. So the customer want the software according to his needs and requirement. Okay, then we also check whether the software responds correctly to all kinds of input. And the third testing parameter is that the time constraint. Here we will check whether the software function within do its function within the acceptable time limit. It means that even if we implemented all the functionality to the software, but the software is not responding correctly within the time limit, then it is not usable. And fourth testing parameter is the usability. Here we will check whether the whether the user can use the software without any delays, lag, like that, any glitches like that, and he can perform the function smoothly. Then we can say that the usability of the software is good. And lastly, we will check whether the software capable of installing and running in all kinds of its intended environment.
Let us look into the static and dynamic testing. Static testing can be used to identify error at the earlier stage of the development. In the static code analysis, the developer checks the design documents and the source code to find out the errors. And along with the error detection, another objective of the static code analysis is to improve the quality of the software. If the software is not readable, then during the maintenance phase it is very difficult to debug and add additional feature to the software. Hence the software should be made more readable. And during the static code analysis, if it is found out that software is not readable, we can instruct the developer to improve the code readability. And another type of testing is the dynamic testing. And this phase of the testing is this type of testing is done at the final stage of the development. And here after completing the software, we put the software in the embedded system, and then we will check whether the output of the embedded system matches the expected output.
These are the stages of software testing. The first stage of software testing is unit testing. A software unit can be think as a block of program which has its own functionality, and each software block is programmed by a developer. And after developing that software block, the developer will test the software block against its functionality. And the second stage of the software testing is integration testing. Here the individual software block combined together to form a combined group together and will test against its combined functionality. And the last stage of dynamic testing is system testing. Here this testing is performed after integration of the entire software blocks, and we will test the software functionality against the expected result of the software, or we will test the software functionality against the design requirements. Let us look into white box testing. White box testing is also called clear box testing, or glass box testing, or transparent box testing, or structural testing. In comparison to black box testing, it verifies the internal structures or working of a program. But the black box testing used to test the functionality exposed to the end user. And the commonly used method for white box testing are API testing, code coverage, and fault injection. The API is an acronym of Application Programmable Interface, and this can be seen in every client server applications. For example, there will be at least one API in every online mobile application or every web applications. And in the case of let us consider the Google search engine case. When we type a keyword in the URL of our web browser, the web browser will send this keyword to the Google API and fetch the result, and it will show in our web browser. Now let us look into black box testing. Black box testing is also called functional testing. In comparison to white box testing, the black box testing, in order to do a black box testing, we do not need to know the internal implementation of the program, and here we can treat the entire software as a black box. And the following are the methods which is used for black box testing. The first method is equivalence partitioning, then boundary value analysis, then all pairs testing, state transition table, decision tables testing, first testing, model based testing, use case testing, exploratory testing, and specification based testing. And for doing this in a black box testing, there is no need to know the programming, but the tester should have a clear understanding of the software requirement and specification. Now let us look into acceptance testing. In comparison to other types of testing, acceptance testing is performed by the customer in their lab environment on their own hardware. And then it's come smoke testing. This smoke testing is a minimal amount of testing to verify the hardware or software is free from basic problem which will prevent it from working at all. Then it's come regression testing. This is used for finding errors after a major code change has been occurred. Now let us see what is sanity testing. Sanity testing is almost similar to smoke test. Here we will check the basic functionality of the software and ensure that it is reasonable to proceed with the further testing. And the next type of testing is usability testing. In the usability testing, we will check the user interface and make sure that the user interface is easy to use and understandable. And finally, we will And finally, the security testing. In the security testing, we will ensure that there is no chance for data leak and intrusion by hackers. Now let us go through the software validation. The software, we know that the customer is paying money for the software, so the software should comply with the customer needs and requirement. So in software validation, we will check whether the developed software meeting all the needs and requirement of the customer. And this software validation, it can be classified into two types. First one is internal validation and another one is external validation. In internal validation, we are assuming that the design documents meet the customer needs and requirement, or the design document fulfill all the customer needs and requirement. And here we will check the developed programs against the design documents. And in external validation, we will ask the customer whether the developed program fulfill his needs and requirements. Even if we given lot of care and attention during the program development, we cannot say that the program will be free from the errors. There will be some error, definitely there will be some errors in the program. So here we use software debugging techniques to find out and rectify those errors. And we can say software debugging is a process of finding and resolving defects or problem within the computer program that prevent a correct operation of the computer software or a system.
These are the steps involving debugging process. The first step of the debugging process is the identification of the problem. Without identifying the problem, we won't be able to rectify it. And the second step of the debugging process is the reproduction of the problem. And because the software is a state machine, the present output of the software will be dependent on the internal state of the software as well as the input. So in order to reproduce the problem, we have to recreate the internal state as well as we have to give the problematic input, and it is somewhat difficult. Sometimes it is somewhat difficult. And the third step of the debugging process is to simplify the problematic input and problematic conditions. And this simplification of this input help to make it easier to locate the problem. And next step of the debugging process is to examine the internal program state by using a debugger tool and track down the problem. And using a debugger tool, it is possible to examine the internal variables and code stack of the software. And final step of the debugging process is the rectification of the problem. Here developer will rectify the problem using by modification of the source code. These are some of the debugging techniques which is available to debug the program. The most commonly used debugging technique is print debugging or tracing. Here the developer will add a lot of print statement or trace statements within the source code, and it will help the programmer to understand the flow of the execution. And another type of the debugging technique is remote debugging. Here the programmer debug the software from a remote machine, and then it's come post-mortem debugging. Here the programmer debug the program from the crash log, which is available after the program crashed. Then it comes record and replay debugging. In order to simplify the debugging, the programmer can be used some tools. The most common tools which a programmer used for debugging the programmer serial port tools and breakpoint tools. This serial port tools is commonly used for embedded program debugging. Here the logs of the embedded system's output is normally displayed, normally sent to the serial port. And using a serial port tool, the programmer can obtain the logs and rectify the problem. And another type of debugging tool is the breakpoint tool. This is commonly used for desktop application debugging. Here the programmer will set a breakpoint in the source code, and the breakpoint tool will give the output, give the variables and internal state of the system at the breakpoint location, which will help the programmer to understand and rectify the issue. Now let us summarize what we have studied so far. Initially we have studied about we have gone through the software testing. This software testing is a activity to check whether the actual result matches the expected result. And then we have seen various software testing techniques such as static and dynamic testing, black box and white box testing, sanity testing, smoke testing, regression testing, etc. Then we have understand what is software validation. In software validation we will check whether the developed program matches the design requirements of the client. Then we have gone through the software debugging. In software debugging we will rectify the it is the process in which we are rectifying the problem, and we have seen various software debugging tools and techniques. Thank you.